Hello, everyone. Joshua Green here. And in this video, I want to be able to do a quick introduction for solving rational equations. All right, so I have an example here where we can start where this equation involves a fraction. And that's really what we're going to begin to look at. It's like what happens when we have fractions. Now, there's many ways to deal with this, but I'm going to solve this one to set up how I want to move forward with other types of equations with fractions. So here we have a two-step equation that we're able to solve with our linear skills, where we add the 13 to both sides. In doing so, we have our variable term plus 0, which will just be the variable term as it is. And on the other side, 13 minus 10 is 3. Now, the thing we have to remember about fractions are closely related to multiplication. Specifically, as long as we remember that a number times its reciprocal equals 1, we have something that we can work with here. And that goes back to the multiplication property of equalities. All right, so here right now, we wanted to write it a different way. We have 1 over 7 times z equal to 3. So multiplication here will help us deal with the 7. Now, you didn't have to rewrite it. You could have just used this step here and said, hey, let's multiply both sides by 7. But the reason we do the multiplication is so that we can get that denominator out of the way, right? 7 divided by 7 is 1, or another way to say it again, 7 times 1 over 7 is 1. With that said, this particular equation would give us the final equivalent equation of z equal to 21. Right, and we like that because at that point we know 21 is our solution. Okay. Now, what I want to show though from my introduction is what happens when we have more than one fraction and we begin to add more to the fractions. So here we now have two fractions, but both numerators, the top of the fractions, have expressions in them themselves, right? So we want to be careful how we handle them. The nice thing about these fractions, though, is they have a common denominator. If we take the same approach that we just saw, we can eliminate fractions by using multiplication. Now, when we use our multiplication, we're going to multiply both sides by the same thing according to our multiplication property equalities. And we want to use the value that's in the denominator. Our common denominator is 3, so let's multiply both sides by 3. At that point, we can do that division we just mentioned, because 3 divided by 3 is 1. And then 1 times anything is itself. So we're left with our numerators there. Now, when we solve this problem, we find that this actually ended up being what we call a contradiction when we deal with this equation. So make sure you watch out for that can happen. All right, when you solve different types of equations, you can expect something that has a solution, or what we call a conditional equation. Here's an example of what we call a contradiction, but also watch out for identities as well. So after doing all that, this is a false statement. So we would say that this actually has no solutions. Okay. Now, like the first one, this just happened to be a linear equation with a fraction. What I really want to be able to introduce in this brief video is what happens when we start putting variables in the denominator. This is where we get into the situation where we need to make sure we understand we're now solving a rational equation. It's no longer linear. And that, again, is because we have variables in the denominators of our fractions. Now, things we have to be careful of, as we kind of just talked about, when we see fractions as closely related to multiplication, and we're able to use division as well. So we have to make sure to go over the fact that when we start dealing with division, there is one thing we have to watch out for. We can never divide by 0. So another way to quickly write that, if you had 1 over x, x cannot be 0, right? That is an undefined value. We're not able to do it. The way that we want to apply that, though, is anytime you're solving, again, a rational equation, we want to take our denominators. In this case, again, they are the same, so we have a common denominator. And we want to state our restrictions. It's always an important thing to do first. And the way that we want to do that is say, hey, the denominator cannot be 0. Make sure you see here it's the whole denominator that we're using, and that both of these denominators are the same. So that's what I'm using over here. With that, we have an equation we need to solve. So subtracting 1 from both sides, we'd have 0 minus 1, which is -1. What that means to us is for this problem, we do not want to use -1. So never plug in -1. Now, what we're trying to do right now is solve the problem to see if there's any numbers that we can plug in to make it true. So when we're done, we need to make sure to check if the number we got is -1. That would be our main concern here. So let's go ahead and start with the solving now. Make sure you remember, as I mentioned, though, it's always important you state your restrictions first. Now, with this one, the denominator is a little bit more involved than what we saw, but it's still a common denominator. So just like that we saw with the 3's on the previous problem, we want to multiply both sides by that denominator. Now, one thing you're going to see here, it's a little bit different, is we need to put it in parentheses because it has 2 terms. It's a binomial. All right, so make sure you're careful with that. Also, on the left side here, we need to use parentheses. We don't want to just use that multiplication symbol because this whole thing has 2 terms itself. We have the fraction term, 3 over x plus 1, minus the second term of 2, right? So we need to make sure to distribute when we do our multiplication. This is one thing you want to be careful of when you're taking the approach that I'm showing here, where you're going to eliminate the fractions, all right? So in doing that multiplication, we do distribute on the left side. I can write it as such. And we want to go ahead and simplify those fractions now because the multiplication allows us to divide those things to 1. All right. And at this point now, we just need to collect what's left over. So we would have 3 minus 2 times that x plus 1 equal to 4x. And at that point, we will eliminate the fractions. We've covered what we want to be able to do when we're solving rational equations. Now, as I mentioned, I've used multiplication to eliminate the fractions, and that just kind of highlighted with what I did here, but there are other ways to solve this equation. Okay, you can go up here and actually do the subtraction here by finding the common denominator and then work the problem out. That's great too. The one thing you'll see here, though, is when you choose to eliminate the fractions, is be careful to recognize that this resulting equation is no longer rational but linear. So we need to go through and follow those steps by distributing and then combining like terms. And then once we get here, once we do that, it's a 2-step equation we need to solve. So let's add the 2x to both sides. That way the x is only on one side of the equation. And then by dividing by 6 on both sides, we'll find that our solution we're actually looking for here is going to be 1/6, which is a good thing to see because remember, we had a restriction when we solved this equation. So when we get over here and we see that this solution is 1/6 equal to x, or x equal to 1/6, depending on your preference in solving, both statements would be the same. Once we get here to our solution, we need to make sure to look back, compare it to our restriction. Okay. And as we stated before, we can't use -1. So 1/6 is a good solution that we can plug in that would make a true statement for both this equation as well as our original equation, right? Just make sure you remember as you do your work, each step is important because each of these represents an equivalent equation that shares the same solution. If you have further questions or concerns, please reach out to me or your instructor so that we can make sure we give you the best help that you need. Have a great day.